Alright, so this is just practicing. And so again, the common kinds that we're going to do integration by parts are going to be exponentials with logarithms, and there's a specific way to do it. Alright, so the second example with an exponential. Alright, so again, I can't use U substitution. If you try it, you'll fail. You'll just keep going in circles. And so this is an example of where I have to use integration by parts. It's an x function times e to the negative 2x function. It's a product. Alright, so I need to rewrite this expression in terms of u and dv. Alright, so remember, I let u be something that's easy to take the derivative of, and dv be something. And so whenever it's an exponential and an x term is always going to be the u. The exponential term is always going to be the dv, because exponentials are really easy to take a antiderivative of. They're easy to take a derivative of, too. But they are simpler to take the antiderivative of than the derivative. If that made sense. Right, so we're going to let x equal u, and then e to the negative 2x dx be my dv. All right, then we take the derivative of the u expression, which again is going to leave me with 1, which is a nice simple expression. All right, we like that to happen. That means dv is a direct substitution. Du is a direct substitution of dx. We integrate this side, which this one's going to become a little messier because there is going to be a fraction. Again, remember, it's the general integral. There's no constant yet. We do the constant at the end. So remember, the derivative of e to the negative 2x, because there's a negative 2x, I've got to take care of that. It's e to the negative 2x divided by negative 2, right? Or I prefer to write them as the fractions. Negative 1/2 e to the negative 2x is probably what I'll use. But either expression is fine. And there's my v. All right, so those are the three values that I'm going to substitute out in this expression. So u is equal to x. dv is equal to either e to the negative 2x divided by negative 2 or the 1/2 expression. And then du gets replaced directly with dx. All right, so I'm going to fill out that formula, which I actually have here, which is nice. All right, this is the formula I'm filling out. So this equals u first, which is x, then my v, which is my negative 1/2 e to the negative 2x, minus my v again, which is negative 1/2 e to the negative 2x, and then just dx, because it's a direct substitution with dv. Keep saying dv. du. Alright, then we integrate that, my next step. So I'm actually going to rewrite this as negative 1/2 x e to the negative 2x minus a negative 1/2 becomes a positive 1/2. E raised to the negative 2x divided by another negative 2. And this is where we tack on the c. And again, I will simplify. So I actually did that here. And I write my simplified expression in the next term. Negative 1/2 x e to the negative 2x. Here, I'm going to take my 1/2 and my negative 2. So I'm going to get a negative 1/4. E raised to the negative 2x plus c. Alright, and so there's the answer. Alright, my general antiderivative of my first original function is that expression. And you can check your answer. I'm going to check it. You don't have to check it, but I'm going to show you that this will check out. It will give me my original. Remember, my original was the integration x e to the negative 2x dx. And so it should simplify to that negative x e to the negative 2x. I can't talk today. Alright, so the first term, I do have to use my product rule. Second term, I don't, because it's just the negative 4 is a constant. Alright, but this one I do. Negative 1/2 x and e to the negative 2x are my two functions. So I get first negative 1/2 x e to the negative 2x times the negative 2. That's the second, negative 2x times the derivative of the first, which is going to leave me with a negative 1/2. Alright, so there's this expression. I've taken the derivative of that. Now the second term, this one doesn't require a product rule. Negative 1/4 is just a constant. It comes along. I take the derivative of e to the negative 2x, which is e to the negative 2x minus 2. That will zero out. And then the hard part about this one is just simplification. Alright, so that cancels. Leaves me with x e to the negative 2x. I'm going to rewrite that as negative 1/2 e to the negative 2x. 1/4 and negative 2 is going to give me a positive 1/2 e to the negative 2x. Those reduce and leave me with what I want. And again, that will always happen. Right? It's the way these work. Alright, so I'm going to go ahead and stop there, and I'll pick up the next example in the next video.